Very good afternoon, student. So today, the concept what we are going to discuss is deep learning unit 2. So very first, before we are going to enter into this, we must know about what is the course outcome to, because according to these concepts, we have 5 different kinds of course outcomes. Okay, so according to each and every unit, we have one course outcome statement. So that this model 2 have the course outcome statement of build a CNN model on the real-time data. So whenever we have the real-time data, how it is going to be operated by this CNN model, that is the very first concept. So we know that CNN is one of the repeated model, which is very opted for the data set, image data sets. Okay. So today we are going to discuss and we are going to start this unit only. So here, what are the syllabus content we have? We will see one by one. Okay. So very first, what we are going to discuss here, what do you mean by convolution operation? So, and what are the motivations we have to become the proposed CNN is a one of the reputed as well as enhanced model. So, what are the motivations we have behind the concepts? Then, what do you mean by pooling? So, these are all are well connected concepts. So, very first, we are going to start with those concepts only. After that, what we are going to discuss in the later classes, convolution and pooling as an infinitely strong prior and variants of the basic convolution function and structure outputs and data types, efficient convolution algorithm and convolution networks and the history of deep learning. So these are the concepts we are going to discuss. Very first today, what is the concept we are going to discuss? So very first, convolutional networks. So here, these convolutional networks, which one is the basic entity is convolution operation. So convolution operation is the basic entity before doing any convolutional networks, we must initiate this operation. Because for example, whenever we are getting the input, how this input is processed and how the input is converted and what kind of output we are getting. This is very, very important. So these kinds of things will be described in the concept of convolution operations. Here, what is the learning objective? So here the learning objects will describe about what is convolutional networks. We are going to start with this and explain the convolution operation and understand the kernels and feature maps, compute convolution output size, and distinguish convolutions from fully connected layers, and apply convolutions to image processing problems. So these are the concepts we are going to discuss in this one. Very first, what we have to start, we must know about what is the convolutional neural network, CNN. So it is a special kind of network. It is specifically operate on the image files. What kind of images we are able to manipulate here? So images, 2D pixels images, 3D pixel images, and time serial signals, audio signals. These are suitable applications for CNN. Because in first unit, the first module, what we were studied, the selection of architectural design according to our application is very, very essential. That you know. Okay, so what I have to explain in the module one, already know that. So we have different kinds of data sets. For example, the data sets maybe belongs to the text oriented or audio oriented or video oriented or image oriented, whatever it may be. What is the specialized architectural design is fit for our data applications. That is very, very essential. So this kind of convolutional neural network is more fitted for image image kind of data sets. Okay, so in previously, the traditional artificial neural network is capable to implement or implement these data sets in a full matrix multiplications. So while we are using full matrix multiplication, it has some issues. So how these issues will be rectified and getting the efficient one means while we are going to the concept of CNN. So CNN means what? It is efficient for extracting the local feature. So in the previous one, which is not familiar to extracting the local features, but it is very clearly and efficiently extract the local features. That is a very, very important one while we comparing our CNN with the traditional network. So now I'm going to start with what is convolution. So it is a, one of the, I said it is a, one of the important entity in convolutional neural networks. So that what do you mean by convolution? So what do you mean by convolution? That is a very, very important. So the convolution is nothing but it is a mathematical operation. So what these mathematical operations will do means while we are getting the input data, there we are going to add some small filter. That kind of filter is called as kernel. So this kernel will be used to do some operation on the input what we have. So that here you can see this formula output equal to input into kernel. So what this multiplication symbol will denotes, this denotes the convolutions. Here the multiplication symbol will denotes the convolution. Okay. So multiplication symbol will denotes the convolution. So that's why convolution is very, very important. It is manipulating the input data along with the kernel filter what we have. So to manipulating these two, getting the new output that is called as feature map. So here four components are very, very important. So what are the four components which are very, very important for the convolution operation means, because here only we are going to start the convolution operations and its related four different kinds of components. While we are executing the convolution operations, it involving four different kinds of factors. They are, first one is input image. What input image we are going to manipulate or we are going to learn, that is the input image. And what is the kernel filter we are going to add on the input image is called as filter or kernel. And sliding operation. Sliding operation is nothing but to move one region to another region. So what do you mean by region here? You may have the doubts. So you must ask this. What do you mean by region? Region is nothing but, for example, while considering one image file, that means one image, that image is classified into different regions. In what basis we are going to classify that region? The region will be classified in the manner of filters. Okay. So here we are already using the filter. Now filter is nothing but, for example, we have to split it into the region. Each region we are applying this kernel filter. So we are getting some value. For example, 3 cross 3 matrix, there we have 9 different kinds of outputs. So those outputs are called as feature map. Okay. So I will explain in the later figures. I will explain clearly. You don't worry. I will explain clearly about this concept. And sliding operation. Sliding operation is nothing but first we have to learn the first region, then first region to second region to third region. Likewise, we have to move. For example, it is starting from this edge. We are slowly move or slide one region to another region. For example, in a 5 cross 5 matrix, if we have assumed, so three region means region 1, move to region 2, move to region 3, move to region 4. Likewise, we are going to cover all the regions. Then we can go for downwards also. So the same will be applicable in downwards also. Okay, so this sliding operation is used to learn the entire figures. Okay, because we know that every figures which consisting of huge amount of pixels. So those pixels will be classified as the matrix. Okay, so those matrix will be learned by this sliding operation. So feature map is nothing but what is the output we have, that is called as feature map. So feature map will provide the output of this. So that is called as feature map. So this concept, feature map concept is very, very essential because this is the concept what we are getting the final output is called as feature map. So input images. So very first, I'm going to start from the very first component, that is a input image. So while we are taking the input images, which is in the collection of pixels. So for your understanding, I'm telling it will take the grayscale images. So grayscale images have the range of pixels from 0 to 225. If a pixel is a black means it has the value of 0. If the pixel is a white means it has the maximum value of 250. So this is the black and white images. While we considering the color images, it is the mixture of three different colors like red, green, blue. So mixture of those colors, we are getting the color of each and every pixels. Here, why the pixel is very, very important? Because we are going to operate on pixels only. Okay, how the pixels will be classified? By using the matrix format, it will be classified. By using the matrix format, it is classified. For example, we will take the grayscale image. The grayscale image will give, for example, we consider 5 cross 5 matrix. So the 5 cross 5 matrix is one of the region. So this region again is moved to the next region. So next region also we have 5 cross 5 matrix. So like this it is going. So that very first input image is nothing but how much of pixels which contain and how we are going to classify those pixels, because each and every regions, what kind of matrix format we are choosing. So three different kinds of matrix format we are able to choose. One is 3 cross 3 matrix, another one is 5 cross 5 matrix, another one is 7 cross 7 matrix. So any one of format we are able to choose. Okay. Then what is kernel? So kernel is very, very important. See here, I mentioned na 3 cross 3, 5 cross 5, and 7 cross 7. These are the different kinds of formats we have. So any one of format we may applying for our input images. So, but only one thing, if it is if you are choosing any one of filter here, that filter is entirely used for a particular images. For example, left corner I am starting and right bottom corner I am going to finish, means entire sliding, entire learning, we must use any one filter only. If we choose 3 cross 3, that is that only filter, we are using the entire scanning. For example, up to the bottom right, we must use the same filter. That is called as kernel. Okay, kernel is nothing but it is a small portion. There we are applying this value. For example, here, what is the value of 3 cross 3 matrix filter value? Filter value is 1, 0, minus 1, 1, 0, minus 1, 1, 0, minus 1. So this is the filter. So this kernel detects the vertical image. For example, this kernel will describe about the vertical image. If it is the horizontal image, so there the filter is different. Okay. So the main purpose of this kind of kernel, this filter is extract the important information from the image, then detect features like what, how many edges we have, how many corners we have, and how many curves we have, how many textures we have, how many shapes we have. Everything will be extracted clearly and accurately. That is the purpose of this kernel. Then third one is very, very important. So here it is a sliding operations. While I'm uh, learning the first square, then I move to second square. So this process to move the first square to second square is called a sliding. Sliding is necessary because while we leave from the first to second, second to third, we must learn the value of we must learn the value of images. So sum of all values, we may get the entire image value. So that the sliding is very, very important. That's why you can see this slide. I have to include. I have to mention the concepts. The kernel moves over the input image one step at a time. At every position, place the kernel on the image, multiply each kernel value with the corresponding pixel, and add all multiplications result, store the result in the output matrix, move the kernel to the next positions. So while moving one by one, finally we may get some collection of values. So those collection of values will give the entire value of the region or the pixels. See here I'm showing one example. Here the input image as 1, 2, 3, 4, 5, 6, 7, 8, 9. So here what filter I'm using? 2 cross 2 filter only I'm using. What is the value of 2 cross 2 filter? 1, 0, 0, 1. So that first I'm taking first to 4 value in the right corner. Sorry, left corner. Left corner, what are the 4 values we have? 1, 2, 4, 5. 1, 2, 4, 5. So while we are applying the filter on the value, what final value I'm getting? 1 into 1 plus 2 into 0. 2 is the input value, 0 is the filter value. 2 into 0 plus 4 into 0. 4 is the input value, 0 is the filter value. Plus 5 into 1. 5 is the input value, 1 is the filter value. So finally, what is the value I'm getting? 6. Likewise, I'm applying the next value, portion. So next portion what I have 2, 3, 5, 2, 3, 5, 6. So 2, 3, 5, 6 means what is the value I am getting? 8. The next what I have 4, 5, 7, 8. What is the value I am getting? 12. The next what I have 5, 6, 7, 8, 9. So what is the output of this? 14. So that final, the matrix value of my image is 6, 8, 12, 4. So this matrix is the output of an kernel. Output of the kernel. After applying the kernel filter, we may get the output like this. So this output is called as feature map. This output is called as feature map. Okay. So here these keywords are notations are very important. What is feature map? So you students, I advise to I given the suggestion to you. So please you have to remember the keywords like feature map. What do you mean by feature map? What do you mean by kernel? What do you mean by filter? What do you mean by sliding? So you must know all these process. Okay, just you have to remember what are the components of the convolution process. So four different components: input and kernel or filter. Third one is sliding operation. Fourth one is output or feature map. Okay. See here, this figure, it's clearly illustrate about how the input is taken, how we are going to applying the kernel filter, and how the operation is initiated. Then what is the final output? That is a feature map. Everything is clearly given. First, we can take the input images. I will explain through the image. First, we will take the input image. It is a grayscale images. Already I said each and every pixels. For example, here one is a pixel. Junction of one is a pixel. It is a first row, first column. Okay. So the second one is what? Two. It is a first row, second column. So it is called as I comma j. Okay. Likewise, it is a input. Then here I am going to applying the filter. The filter is a 3 cross 3 filter. So that very first left side, first three row and columns will be taken. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So what is the value of this? So to applying this filter, we are getting some value. So that is final value of this region. Likewise, we are going to slide the next region and next region and next region. So totally, how many values we have? See here, 6, 8, 7, 12, 14, 11, 7, 8, 9. If we have 3 into 3 filter means total 9 different values we have. Those 9 values are listed here. Okay, right. So are you clear about this? See here in the bottom how convolution works. Summary is given. Input image is taken. Kernel is going to apply. If it is if it is input image is a 5 cross 5 input image. Kernel we are applying is 3 cross 3 and sliding operation will be performed. So that is a combination of multiply and sum. Finally, the output is feature map. So what is the final output I am getting? For example, image is a 5 cross 5. But as per the kernel filter, we are getting the output as 3 cross 3 matrix. Okay. So this figure is in-depthly explain about the concept of convolution operation. Okay. See here. This figure illustrate how the sliding will be performed. See the right side figure, kernel sliding over the image. Here, two things, two keywords we must remember. One is stride, stride, stride equal to 1, no padding. What do you mean by padding? What do you mean by stride? Padding is nothing but if it is sometime we need to preserve, we need to ensure the value of that matrix, we need to add some zeros. Okay, so padding is nothing but it is adding some additional zero to preserving the output of the result. Output of the result. So if it is needed, we have to add. If it is not required, no need to add. But we must know about what is padding. Padding is nothing but adding the additional zero to ensure or preserve the output. Okay. Apart from that, slide is nothing but in how many pixels it is jumping for sliding. For example, sliding, we know that it is moving. See here step 1, 1, 2, 3, 4, 5, 6, 7, 8, 9 is taken. The next case, step 2, only 1 pixel is jumped so that it is taking 3 input values as 230, 561, 893. Next, what I am going to choose 301, 612, 934. So likewise, I am choosing. That's why if I have 3 cross 3 filter, the output must be 9. The output must be 9. See here how many tables are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is the important. Here, what are the key points we must remember? The kernel size never changes during the convolutions. That I said earlier. In the previous ANN, there is a chance to change the kernel value. But here kernel value will not be changed while finishing the entire process. The same kernel value we need to maintain. Okay. The kernel slides over the image one step at a time is called a strider. Okay. Each positions produce one values in the output feature map. Then different kernels produce different features map. Okay. So based on the kernel only, how many outputs we are getting, how many values we are inducing. Likewise, everything is fixed based on the kernel what we are going to use. Okay. So, what is the purpose of this feature map? The feature map highlights many features while we are using the image data sets. For example, if you want to learn vertical image or horizontal image or corner or curve or object boundaries, it is suitable for handling such kind of data sets. And apart from that, different kernel generates different feature maps. Okay. For example, one kernel detects vertical edge, another detects horizontal edge, another detects diagonal edge, another detects textures. So that each in every kernels we have to use different kinds of inputs. So this is important things. What is the mathematical notations you have to use for representing the convolutions? So convolution will be represented two different types of categories. One is the formula for audio signal is differ. The formula for video images is differ. The very first formula will describe about the formula for audio signals. So what is the formula? S of t is equal to integral of x of a, w, t minus a, and d. Okay, so this formula is mainly used for continuous signals such as audio signal, radar signal, sensor signal, communication signal. So here what x of a is indicates it's an input signal. W of t minus a indicates weighting function. D of a is a very small interval of integration, and integration is a sum of all values. So one more thing, what is the output of this is the previous case is the audio. But already we know that CNN is more suitable for the videos and images. So that how the images will be treated by using this convolution process. The formula is S of I comma j is equal to summation of m and summation of n and capital I of I plus m comma j plus n into k of m comma n. So here many notations we have to use, and I will explain the meaning of each and every notations. Here I represents the input image, K represents the kernel, S represents the output feature map, I comma J represents the position of output pixels, M comma N is a position inside the kernel, and summation is add all multiplication result. And if we have to find the final output, what is the formula we must use to get the final result means output equal to N minus F plus 2P divided by S plus 1. So 32, for example, input is 32, filter is 3, padding is 1, stride is 1. So we have to apply the input value on the formula. So what is the final value we are getting? 32 minus 3 plus 2 of 1 divided by 2 plus 1 is equal to 32. So that is the final result. So here padding means what? Stride means what? Clearly I am giving here. Padding is the process of adding extra rows and columns for ensuring the or preserve the size of the output feature mean. Stride is nothing but it is the number of pixels by which the kernel moves. That means number of pixels it is jumped. Okay, single pixel or double pixel. Maximum we are able to jump 2 pixels for sliding operations. Okay, so that up to this, the concept of convolution operation is over. So it is a very interesting. Once again, you have to remember what are the important components we have under convolution operation. So convolution operation is having the component of very first input image and kernel filter, and third one is sliding, and fourth one is output. Okay, so output means it's a feature map. Okay, thank you, student. Today we will close the class now. Then tomorrow we are going to discuss about the concept of motivation and pooling. Okay, what are the motivations which are initiate as to do for next concept is we will discuss on next class. The next class we are going to discuss about the concept of motivations of convolutional neural networks and pooling. Okay, student. Okay, thank you. Thank you for your patience. We will meet on next class. Thank you.